Let me just grab the course. Mm, Screen first. Hope that. So is it visible, my screen?
Yes, I can see your screen fine. Looks great, somebody. Yeah, super.
Okay. So this will be our last week for studying Python for data management. And you will see that everything will kind of like sort of combines, and we will
Right.
discuss all of the concepts that we have studied so far.
So
So
this is
first
our
thing is,
last
yeah,
lecture. It's our last lecture, is it?
yeah, this is the last week for Python for data management. Okay.
I'll miss our weekly sessions anyway. That's why.
No, you can email me anytime if you have any query, so I will
Thank
be
you,
able
somebody.
to answer that.
I
So
will do that. Yeah.
So basically, what we are doing is last week we understood that Python Pandas library is kind of like helpful for doing some management of the data and maintaining the data in a certain sense that we can carry on some analysis. So one of the things that we need to do is pre-process the data.
Yes.
Now, what I mean from pre-processing is that we need to pre-process the data for making the data compliant for further processes.
Mm.
Now, if it is like using machine learning, or if it is just analyzing the data for some specific cases, so we need to make the data, it's like we need to enhance the quality of the data so that the analysis would be good enough, or the machine learning model would be good enough to perform the task that we need to do it. So it's like it depends on the requirements. Let's say if we are doing training of AI models, so we need to scale or we need to normalize the data.
Mm.
If we are making an analysis, so if it is a statistical analysis, we need to make the data compliant with a certain probability distribution. Or if we are kind of like analyzing the data for financial institutions, we need to make the data compliant in a certain way so that it would kind of like fulfill all of the requirements and all of the characteristics of the data, so that it could be processed for further analysis. So we need to just kind of like mark the check on the checklist that we have for the data quality. And one of them is tidying the data.
Mm.
So in this module, in this submodule, we will introduce the concept of advantages of tidying data, how to tidy data sets in Python with pandas,
Mm.
and further tidying it with Altair. So Altair is kind of like a package, a separate package, and we will see how we can use it. So the motivation is that structured data sets are easier to clean and analyze. And when I say structured data set, it's like a tabular data set. A
Mm.
tabular data set which has its like predefined structure, that we have some certain headings or certain indexes, and then there is a data that corresponds to those indexes, and um, kind of like specific columns.
Mm.
Okay. And we have to confirm with best practices and tooling. And it's like optimizing data organization for storage and sharing. So if we can share the data, we can store the data, we can store the modified data that we have after the tidying process. So the principles and influences are that the principles of tidying data come from the database world. If you have studied the databases, we need to have certain partitions, we need to have table spaces, we need to have the data that is kind of like um, corresponding to the task at hand. So we do not need to use the whole data if the whole data is not related to the task. We can use a subset of data, or we can modify the data in certain sense that it would correspond to the task at hand without utilizing additional data that could disrupt the analysis in any case. And it is based on mathematical relations like set theories, and the data can be represented in like multiple tables. So if we have multiple tables, we need to have a common attribute which we can use to join the multiple tables. Or if our analysis needs to have multiple tables like in a distributed manner for the analysis, then we can divide one table into multiple tables. Okay. So it kinds of like makes it easier to retain only what is necessary in the most compact way.
Mm.
So we do not need to process everything, but we need to process the things that are what we say is important for data analysis. So the basic, we will see the basic terminologies. So the basic terminologies is the data set, which is uh, basically the collection of values, and each value belongs to a variable and an observation. So there are multiple names to this. Some studies suggest that a variable is like where the data is stored, and the observation is the instances. So they can call instances, they can call rows, and variable can be considered as, let's say, the variable is something that the table is stored in,
Mm.
and there are columns. So the columns can be considered as features or attributes. So these are just the naming conventions. So if we are using observation, it is the same as instances. Okay. A variable contains all the values that measure the same underlying attribute. Now here we are using attribute. We can also use features. So in machine learning terminology, they are called features. And observation contains all the values measured for one unit example. So I'll just show you the visualized way. So you can see that these are the variables where the values are stored. These are the observations. So observations are instances, rows, and the values are the values that are stored in the variable.
Okay.
Okay. Okay. So what we need to tidy the data is that we need to consider each variable that forms a column, and we need to look to each observation that forms a row, and we need to see each type of observational unit that forms a basically table that is composed of variables and observations.
Okay.
But common untidiness issues are like column headers are values, not variable names. So sometimes it's like if you are carrying a survey, the variable name is the value itself.
Mm.
Like let's say less than $20.
Mm.
So basically this is a value, and sometimes it's the name as well. So we need to do something to make it like replace the name as variable name, and then do something with that particular column. Okay, and then there are multiple variables that are stored in one column. So multiple values correspond to the same characteristic, but they are stored in a single column. So we need to separate them out. And then variables are stored in both rows and columns. So we need to kind of like tidy this particular characteristic trait to make it more what we say is analysis compliant.
Yeah.
And multiple types of observational units are stored in the same table. So if there are multiple types, then we have to separate the table so that they could be processed easily. Now, in this case, you would see that column headers are values, not variable names. So this is one of the example of untidiness which we need to modify or which we need to deal with. And you can see that some headers are values, and the headers need to become values in a single column. So what we can do is we can just make a single column and replace all these values in this. Okay. And of course, the table width will get longer because of this, but it will get narrower as well. Okay. So in this case, you will see that some headers are values containing two values per column. So you can see that there are cases and there are deaths, and these basically are the values, not the cases. So what we can do is we can replace them with a value, and then we can use another name which is a status and the country. Okay. So cases, country, headers need to become values in a single column and split these columns further into two. So we can split these columns as well. In this case, you will see that rows duplicated. So these rows are duplicated in this case. And what we need to do is we need to make them in a single row rather than having a duplicate rows. Daily columns become rows, and pivot table for column rows can be maintained or can be modified in a certain sense. So in this case, we have days, and instead of using NaN, NaN, NaN for all those, what we can do is we can just use Tmax and Tmin, and the max value and the min value. And the max value can be like at D30. So this is the max value, and the min value can be anything within this row. Again, the track information here is redundantly reproduced for each observation. So we can just omit it, or if we can kind of like split it into two tables, one for the track details and one for the weekly ranking. So this is basically called code data normalization. Now, what we can do is we can use the tidying data with alter package. So Vega alter, often referred to as alter, is a Python library. We'll see how we can use it. It offers a user-friendly API on Vega Lite grammar, and it allows you to explore data with minimal code writing effort. So there are data sets, sorry. So there are data sets already available with Alter. So what you can do is you can just import the data set with one command, and then you can use those data sets for further analysis, for further visualization. And this is one of the examples. So first you can kind of like install this Alter and Vega datasets with pip. We have already seen that how to install it and how to install packages using pip. We have already seen about pandas and numpy and all that. And once it is done, we can import Alter as whatever namespace we suggest. And from Vega datasets, we can import different type of data. Okay. And then we can visualize it. So I'll show you some of the examples as well. Okay, so before going further, let me see if the tidiness. Okay, so tidiness is already here. So what we can do is we can just jump up to Jupyter Notebook, but before going there, before getting any what we say is uh, what we can do is we can also open Anaconda prompt, and we can check whether the packages are installed or not. Okay, so what we can do is we can use this pip install alter and vega underscore datasets. So let's see if they are installed. So they are not installed. See, they are downloading. So of course, once so they are installed now, and once they are installed, we can use them in our Jupyter notebooks.
Mm.
So let me just make a new Jupyter notebook here. Okay, now once it is installed, what we can do is we can just import the packages. So let's say we import the package pandas and we import alter as well. Okay, let's see if that works. Okay, it works. So I think the packages are installed correctly. And what we can do is let's check if Vega datasets work. Yes. Okay, so Vega datasets also work. So it means that it has been installed correctly. So let's say we have a dataset and we want to read the dataset. We have already covered this in
Mm.
pandas.
Good.
So the data can be okay. So it can import the data. So now what we are doing is okay, let me add a comment. Let's check the type of data that we got. And what we can do to find this is movies underscore df is of the type, and then we can write type. So it's the type of data frame. Okay, so it means that it is what we can use it with pandas, and we can also check its shape. So what we would know that how long is the data set. So there are
Mm.
3201 observations
Mm.
and 16 variables. Okay, and what we can do is we can use head as we did previously,
Mm.
and we would see that what kind of data is this. So this is the title of the movie. This is the gross, like how much it has grossed in US, how much it has grossed worldwide, what are its US DVD sales, what was the production budget, what was the release date, what was the rating, what was the running time, who was the distributor, and other informations.
Mm.
So once we know about it, we can just use this because it's a Panda data frame. So we can use
Mm.
all of its commands right away. So these are all the columns that we have. So if we want to just extract the year, let's say we want to uh, now use the to underscore date time, which is pandas characteristic that we can use, pandas function. It converts the column release date here. So release date, if you will see this one, June 12, 1998 or August 7,
Mm.
1998. So it would convert it into a real date and then extract the year value from it. So later we will be using this newly created column in our visualizations. So let's just use it here. What we want to do is we want to use date time and we want to give the value as an input and we want to format it as, let's say, mm, like this,
Mm.
and we want to extract the year. Let's see if it works. So we want to create this column. So we are creating another column,
Okay.
and we are creating the column from release date, and we want to apply the function that we have just written. Let's see
Yeah.
if it works. Okay, what's the error here? Okay,
There's a data set of delete.
yeah, so it's okay. So let me just, I think this is the problem here. Okay. So here should be the capital Y, not the small y.
Okay.
Okay. And once we have this, we can again check what columns do we have. And now you can see we have here, we have added one more column.
Perfect.
Okay. And now what we will do is we will move on to create some plot. But before we do that, we need to run this piece of code. Okay, so I think this is hmm, hmm.
If we want to be done, be reinstalled by using pip rather than conda.
So so it changes with respect to the version number.
Right.
So of course I was familiar with the older version. So in
Yeah.
newer version they need to have this installed.
Yeah.
Okay. And it will install all other packages that are associated.
Yeah.
So it should work now. Let's see if it works. No, same. So what we can do, sometimes it doesn't kind of like um, what we say is take effect instantly.
Yeah.
So what we can do is we
Restart the
can
kernel.
restart the kernel.
I some I have been doing that loads of times.
Yeah.
Um, loads of times.
So what we can do is we can just run each command because we need to have this data for visualization.
Mm.
I hope it should work. Why?
Well,
You must. So we have already installed it. What's the problem here? Okay,
you
let's
want
see.
you want the machine to you want you to reboot the machine.
Uh, I guess we have done this already.
Yeah.
Okay.
Is there a difference between using pip and using conda in terms of the machine inside, or is the machine treated as the same?
Uh, how about we do from here? So let's say import health and Still the same problem.
Mhm.
Already did that. Oh, mhm. I guess there is a problem with this package. Okay, let's try one more time. If it is not working, okay, let me just see. Hmm. Okay, we can go to the troubleshooting, but it will take a lot of time. So
Yeah.
let me just kind of like see another alternative so we can use this.
Okay.
Yes. It should work. Okay, so let me just see if I can do anything else. So let's say if I can do another example. Uh, if this works. Maybe search PDF. No. Yeah, so it requires something. So we'll see this package. I'll just post the code if there is a breakthrough in it. I would see what problem it is. So
Okay.
meanwhile, what we can do is we can explore more with the pandas.
All right.
So let's say if we have created air, okay,
Mhm.
and what we want to do is we want to count the values. So it would tell you that how many movies were there in, let's say, 2006 or 2005, 2002, 2004.
Mm.
And so what we want to do is we want to put our focus on year 2000, let's say, and we want to make a new data frame with only movies that have been released in 2000,
Okay.
and it should contain 188 rows. Okay, so how we can do that? We can make another variable, and we can use movies underscore df, movies underscore df, and here, and it should be equal to 2000.
Yeah.
And if we just see if we have done everything correctly. So yeah, so there are 188 rows in the data frame.
Right.
Okay, and so I'm not sure what is the problem, but let's try this one more time. So basically, this is the mark property, and
Hmm.
if it works for now, but will it work if I would say so? This is just um, kind of like adding a mark point that we want to mark it with the circle,
Right.
and we have already done mark point. It works. Let's see if it is it on code. Okay, so I'm not sure. So I think that's the problem with the earlier error, that it is not recognizing. That is why it's not easily visualizing in this.
Okay.
Okay. But let me see if I can do something else.
Yeah, that's
So
all.
what we are seeing is we are seeing the production budget and worldwide gross. We have
Hmm.
created a plot, and you will see that these there are some movies that have the production budget of 80,000, but it has only made around less than 50 million. So
Hmm.
that's a kind of like flop. And if you go further, if somebody has used 80 million budget and had 100 million but like gross, worldwide
Hmm.
gross, or like 200,000 200 million worldwide gross, or 300 million worldwide gross. So this is a kind of a correlation between these two variables.
Hmm. Yeah.
So it's like we didn't have to do much. We got familiar with some terminologies, and we can make this graph more interesting rather than the points all being marked with the same circle size. What we can
Hmm.
do is we can try to make the pointers as big or small as their corresponding gross margin or the
Hmm.
gross amount that they have done. So for this, what we can do is we can just use the size feature in the mark point. So if we use the mark point, and we can use build equals to true, and we can add here L dot size US underscore gross. So now you can see that the one that has grossed more are represented as a bigger circles,
Yeah.
and the one that have grossed lesser are represented as smaller circles.
Hmm.
Okay, and then uh, what we are doing here is just representing the production budget and the worldwide gross. Now what we are going to do is we are going to keep the graph interesting by introducing one or more information we have on the data set. Like let's say major genre. Okay.
Hmm.
So we'll give each genre of the movie its own color by using the color feature and add more some transparency to the color, like let's say opacity value. So
Hmm.
what we can do is we can modify this further, and after the size we can add L dot color, and
Hmm.
we can put another attribute that is available in the data set, which
Okay.
is major genre. And instead of just using color, we can set an opacity value of let's say zero point 0.7. Okay.
Hmm.
Now you will see that the colors are basically representing the genre. So
Yeah.
now we can analyze that what kind of genres make more money and what kind of genres make less money.
Mm.
So this is kind of like a way to analyze it in a qualitative way.
Yeah.
And this is already good, but of course, not good enough. It would be great if we could move around the plot and also see details about the movie that the data point represents. So
Mm.
what we can do is we can add one thing which is tooltip.
Okay.
Okay, so if we want to add the tooltip, what we can do is, okay, I'll just use this. So tooltip, we will add this in the encoding as well. Okay, and we can add the tooltip with, let's say, title,
Yeah.
and we can add more by just adding what kind of information we would like to get with this. Like this.
Mm.
If we do this, oh, what happened? Tooltip? Oh, sorry. Yeah. So T should be capital in the tooltip.
Okay.
Okay. So it's
Yeah.
like if you will go to any circle, it will just provide you the title of the movie with the production budget, the worldwide, and the US gross.
Yeah.
So this is how the tooltip works. So of course, it's something very interactive, but remember that we want to use Alter in the first place to be interactive. So we
Yeah.
can make interactive visualizations. So
Mm.
Tooltip already introduces some interaction when you hover around the data points. However, we can add more functionalities through interactive. So if we just use interactive here, keeping all the things same.
Yeah.
So what we can do is you can just like zoom in, zoom out, like you can make it move around. So it's like it's interactive with respect to users. Okay, so this is I'm zooming out, I'm zooming in.
Mm.
So I want to just focus on something that has grossed more, and I want to just move around like this. So this is the interactivity that we can do.
Okay.
So again, adding a simple piece of code like interactive can let you zoom into a particular area, fixing the axis value automatically. And there are many more advanced interactive features that you can add to your graph. Like you can add more parameters in the interactive one to make it
Mm.
more user personalized. But again, it's like one more thing that I want to showcase is like let's bring in all the data points and put them in our graph. But again, it will be too much to put all the data points in a single visualization. So we
Mm.
definitely want to separate them on the basis of the year. So what we can do is we can use advanced selection property like
Mm.
this. So let's say, let me use select here, and we can use alter to write selection single. And what we can do is we can use name, we can use field, that which field we want to focus on. And
Yeah.
okay, so we have already considered this. Now let's see if I can do the same thing that I did before. Hope it works.
Yeah.
So we have to do mark point and this build to, and we need to encode. And for encoding, we can use the same things as before. So I'll just copy this encode thing.
Mhm.
Mm, yeah, like this. Okay. So I think that everything is production budget is there, worldwide gross, US gross, and major genre is there that we have considered, and then the opacity value, and then the tooltip. So in the tooltip, we just have to use this now. And then from this, we have to use add selection that we have designed. We have to use select here, and then we have to transform filter, which is select underscore here. I hope it works.
Yep.
Okay,
Awesome.
so it's bind. Okay. Okay. So we need to do this. It's hmm, value. Okay. Let me check it again. What we have done. So okay, we have selected single. We have name. We have fields. We have init. And we have bind. We have binding range. Um, I guess that's it. So I hope that I have written everything here correctly. So it's add selection. Hmm, everything seems fine, but what is the problem here? Hmm. Put keyword argument value. I think it would show me here. Okay, select here. L dot selections single. So the error is in this.
Is it the fact is not? It's not the fact that maximum is 200, 2000 46 because obviously it's only 2024. No.
Yeah, so no, the thing is that it's 1928. I think it's fine. What is the problem here? Hmm. It's name with the spacing. I'm not sure. I don't think the spacing is should be an issue, but what is the problem here? I think there is a change in the syntax, maybe.
Yep.
So I need to see what is the problem here. Hmm.
Oh,
Okay, select underscore here, select underscore here, it's the same. And transform underscore filter, select underscore here, it's the same. Yeah. I think there is some issue with the syntax. I need to check. I'll get back on this. So basically, what we can do is the idea is that you can apply some of the filters here
right.
using
No.
alter. Okay.
Well, certainly, I mean, I've got the very good impression that
Yeah, yeah.
the package alter will give you an ability to sort of like you can currently do in Microsoft, obviously in Mathematica as well, which I also use. But I mean, it gives you an ability to get in and build very much interactive graphs. And I'm a very strong believer in visualization in terms of communicating messages. And when your colleagues were doing the very first course I did in Foundation in Artificial Intelligence, they spent the time actually dealing with Tableau and spent the first 2 or 3 lectures basically communicating all this in graphs. So that was our first exercise.
So see, you can use different tools as well. It's like this is not
Mm.
just a single visualization library. There are many others.
Yeah.
So if you can use ggplot, you can use others. It's just one of the tools. So if it
Mm.
doesn't work for you, you can use others.
Mm.
It doesn't matter that you should use, I am not suggesting that you should use this, but it's just one of the examples
Sure.
that how you can use interactive plots in this case.
Yeah.
Okay, so we'll discuss other things as well. It's just like the visualization was a part, and it kind of like helps a lot if you
Mm.
visualize it in a certain way.
Yeah.
So let's go to other sections, which is data transformation and encoding. So in this case, what we will do is we introduce the concept of handling missing data. So if there are any missing data, how do we handle them? How do
Mm.
we use some strategies? And
Mm.
how do we use NumPy and Pandas to deal with the missing data?
Yeah.
So of course, we can deal with continuous data, which
Mm.
is unbounded. And the problem is that they use real numbers or they can use integers.
Mm.
But it's like it's continuous. So it's not it's like they are real values. So it's if you are predicting housing prices of
Mm.
something like a house in a certain area. So there are no categories. It can be like 1001, it can be 1002, it can be 1003, it can be 1000, it can be 2000, it can be 10,000. So there is no category, but there are categorical data as well.
Mm.
Like they can have a small cardinality, they are dependent on numbers or strings. They can have hierarchy and like the ordinal data, or they can be nominal data.
Mm.
So in this case, what are the data quality issues? They can be from data sources. So if we combine multiple data sources, there can be quality issues. Automated collection error.
Mm.
So if we are collecting the data in automatic manner, maybe users have not uh, entered the data correctly. So there
Mm.
can be data quality issues.
Yeah.
Incompleteness. So the data
Mm.
has not entered in a complete manner, because sometimes we do survey and people do left out some of the things that are not
Mm.
um, essential. So there can be incompleteness. There can be an error with manual data entry. There
Mm.
can be an error with the logic. So if we are not
Mm.
using correct syntax, or if we are not using correct logic, then there can be an error, and there can be a value bias as well.
Mm.
So sometimes people, it's like if I do not have enough time and I think that I would just do all 555, which represents strongly agree.
Mm.
So I can just do
Mm.
that if it is a compulsion for me to fill the survey.
Yeah.
So that is kind of a value bias.
Mm.
So dubious cardinality means that it is just one value, that,
Mm.
as I suggested, it can be
Mm.
like everyone has just pressed five, like strongly agree with everyone, and it is inappropriate to column type. So the data that has been entered is doesn't correspond to the column type.
Mm.
Categorical type, but too many values. So let's say you have 100 encoded values and all represent different things. And
Mm.
continuous type, but too few.
Yeah.
So all of these can be can affect the cardinality.
Mm.
And then there are invalid data types like strings where numbers are expected and numbers
Mm.
where strings are
Mm.
expected,
Yeah.
non-binary Boolean values or invalid categorical values or values out of expected range, which is outliers.
Yeah.
Okay. And outlier is kind of like very important. So if you have to deal with outliers before doing any analysis. So what are outliers? They are far from central tendency,
Mm.
and they are kind of like nonsensical max or min values. So let's say if you are doing an analysis that what is the average salary of a person in company X, and most of the salaries are like there are let's say there are junior programmers, there are senior programmers, and there is kind of like managers, and there are HR people. So all of their salaries will be in a particular bracket. But if you will add CEO in this, then his salary may be 10 times more than senior programmer.
Mm.
So
Yeah.
what it does is it kinds of like bring out an outlier. So if you will average all of those values, then the average value, the average salary of it is automatically increased, which is not the
Mm.
reality.
Mm.
So that's why we need to extract out the outliers and then perform the analysis so that we can get the real analysis, the real numbers that are representative of the situation.
Right.
So what it does is it brings out large relative gaps between quartiles, and it is again data set dependent. So we have to check that what kind of data is outlier in this case.
Right.
So why clean data? Of course, we need a uniform organization. It and we need to store it. So clean data is more easier to store and process. We need to eliminate errors, and we need to have higher quality input so that our analysis could be qualitative, and our analysis would be more reliable if the data is cleaner, and our AI models which are trained on this data would be more efficient if the data is cleaner.
Okay.
So how do we handle outliers? One thing is that we drop the rows with missing values or outliers. but again, it subjects to acceptable loss in data samples. So if your data is already too small, and if you will just remove the missing values or outliers, then maybe your data set will be very small to deal with.
Yeah.
Um, what we can do is we can estimate a replacement value, like we can
Mm.
replace it with median or recomputed min or max.
Mm.
Uh, and what we can do is we can do a unique category flagging.
Mm.
So we assign a specific category for a missing, like 99. So
Yeah.
if there is no value of 99, we can use 99 as a categorical value to represent the NA or not a number.
Mm. Yeah.
So in this case, you will see that the data is quite small, like it has only 16 rows, but there are many NaN values. So if you will just eliminate them, of course, there will be nothing left.
Mm.
Okay, so we need to replace them with any value, or we need to replace them with median or something to get going. And pandas have different attributes for it. So let's say if you are reading a CSV file, and what you can do is you can write this fill NA. So what it does is it will fill the missing values with the like if the value is NaN or with 0, then it would fill out the missing values automatically. And if you will use method equals to pet, then it will fill out the missing values with previous ones, like the previously used values. And if you want to replace the NaN values with a categorical value as we suggested, a
Mm.
specific, then what you can do is you can use replace
Mm.
command. And for replacing command, you have to provide that what to replace and which value to replace.
Mm. Yeah.
And then what you can do is you can use interpolation. So interpolation does what it does is it takes on the nearest values, and based on the nearest values, it kind of like predicts that what the value should be, and it like fills in or replaces the missing values. So these are some of the commands that can do the filling of the values automatically using pandas.
Mm.
Of course, the data size reduction is one of the things that you can use to do the to clean the data or to make the data qualitatively good. But it depends on the situation that what is the current data size.
Mm.
So if
Mm.
the data is too long, you can of course reduce the data size. If the data is random or stratified subsampling has been done stratified subsampling or random subsampling, then you can use data size reduction. If you have too many attributes that are redundant, then you can use data size reduction. For instance, if you are carrying out like okay, so if a person has high cholesterol and that person has high blood pressure and that
Mm.
person has like let's say low sugar, and the person has let's say heart problems. So in this case, if there is a medical person, he would suggest that the high blood pressure and the high cholesterol are kind of like highly correlated, and they provide redundant information. So what I can do is I can remove one of the values so that it would reduce the data size, but it would also maintain the integrity of the data size and the analysis. So in that case, we can remove or we can just reduce the size of the data. Okay. This include eliminating unnecessary columns. So we will see one of the examples here now. Um,
Yeah.
So let me just go back and okay, so let me just remove this, open a new one. So let's say we deal with a data set.
Yeah.
And what we are doing is, let's say we will deal with a data set with Melbourne housing, so like values.
Mm.
So let me read the data. I hope it's available in my directory. Yeah, it's available. So it's Melbourne housing data set. And
Yeah.
if we just check, this is the data set. So whether it is in suburban or not, what is the address, how many rooms are there, what is the type, what is the price, and all that. Okay. So it has 13580 rows and 21 columns. What we can do is we can use this to see whether there are uh, kind of like uh, any null values. Okay.
Right.
So what we can do is we can print out. So it will check if there are any null values and then it will sum up those null values. So in this case, you will see that the car has 62 null values and building area has 6450 null values. Air built has 5375, council area is 1369. So how do we deal with the missing values? So one is, the first is deleting the column with missing data.
Mm.
Okay, so we can just delete the column. So in this case, what we can do is we can write updated df, and now what we can do is, now in this case, the most were building area.
Yeah.
So let's see if there is any building area. So now we do not have any building area in this. Okay,
Right.
and there was air built. So let's see, we do not have any air built as well.
Yeah.
And there was council area. So there is no council area now. And there was car, and I guess there is no car in here. So what we have done is we have just deleted the columns with the NA values.
Mm.
Okay, and you can have the different possible values. Like you can do this for like you can um, fill the missing values with the mean. Okay, mean or median, as I suggested, or you can fill the missing data with a mode. You can fill the numeric value like 0 or minus 999 or some other number to recognize that these values are NA, or you can fill the categorical value with a new type for the missing
Mm.
value. So what we can do is we can use this updated DIF equals to DF,
Mm-hmm.
and then the updated DF would have building area, which was omitted. And now what we are doing is we are filling out the NA values with mean. So it will just fill out the NA values in building area with the mean of the building area. Okay. Similarly, what we can do is we can do it with the other attributes.
Yeah, yeah, both.
And we can fill this with the mode instead of mean. Okay. And we have council area. And we can fill this with the uncategorized.
Yeah.
Okay. And let's see if this works. Yeah. So now there are no null values. Okay.
Okay.
And let's say we use this again. So this is updated df, right? Is null, and we want to have some of it. Okay, so we have not dealt with car.
Mm.
We have dealt with air build, updated df, air build, updated. Okay, so let's deal with mean. Yeah, so air build is also 0.
Mm.
Okay, so maybe there was no value to replace with the mode. That's why it was still giving. But when we use mean, it would replace it with the mean. Okay.
Yeah.
So we have not dealt with car yet. So car has still 62 values, but others have been dealt with, and others have been kind of like replaced with the missing values.
Yeah.
And this is the finalized version. So this is how we deal with the missing values, and you can use pandas to deal with it. Now let's talk about data normalization and scaling. So why it is important? So we need to introduce the concept of data scaling and normalization and how to encode data columns for a specific task. Remember in Alter, we were encoding it. We were encoding the task with air that we used. And now what we will do is we will use NumPy and pandas to encode the data, and let's see how it does. So why are scaling and normalization important? Of course, it is a critical step in data preparation and wrangling, and we
Mm.
often feed the data to AI models. And in order to train those, the models are pretty picky with inconsistent data. So scaling and normalization kinds of like helps to better analyze and compare the data in that sense. So why we need data scaling? So let's say if you are dealing with the value temperature, and then
Mm.
if you are dealing with the value of, let's say, salary. So temperature value is around, in the centigrade, it's around 0 to 50, or let's say minus
Mm.
20 to 50. And then in the
Mm.
salary, it is kind of like from 2,500 to, let's say, 5,000 to 6,000 or more. So there is a
Okay.
huge difference between the scales. And if you are familiar with machine learning or AI models, they tend to deviate towards the bigger values.
Yeah.
So it's better to kind of like scale the data or normalize the data in such a sense that they should represent the same scale or same
Mm.
probability distribution. So it would
Yeah.
help the machine learning model to train in an effective way. So what
Mm.
if we don't scale? One other example is a comparison of dollar and Japanese yen. So
Mm.
their currency, of course, their currency is kind of like uh, it's like it doesn't mean that the Japanese economy is lesser than US economy, but it kind of like gives that impression if we do not scale.
Yeah.
So another example is in this case, volume is given in liters, weight in kg, and it's hard to compare the way of values. So volume is around 1 or like 0.9 or 1.5, and the weight is from 790 to maybe 1100 or something.
Yeah.
So scaling makes them more closely comparable. So what are the scaling approaches? Either we can use mean normalization or we can use min-max normalization. For mean
Mm.
normalization, what we have to do is we have to compute the mean and the standard deviation. And this is the
Mm.
formula. So any value
Mm.
will be subtracted, like mean is subtracted from the value and divided by standard deviation. So the resultant data would be kind of like compliant with normal distribution.
Okay.
So in this case, you will see that if we do not normalize, this is the probability distribution. If we normalize, then it follows the Gaussian distribution, which is more effective and
Mm-hmm.
in terms of like analysis and in terms of training machine learning models.
Mm.
So why they are important? Of course, avoiding scale sensitivity and scale importance, like dollar yen case. And if the data is scaled and normalized, it would improve the AI model training, and of course, it will also improve the prediction as well.
Yeah.
Model convergence will be faster because the values are in the range of 0 and 1, or like they are on the same scale. And the interpretation would be easy with respect to model performance. So how can we scale the data? We can use mean. So we can calculate the mean, we can calculate the standard deviation, and we can use like we can have iterative value to kind of like compute the scaled or normalized version of the data set.
Mm.
So we can either use this mean and standard deviation based scaling, or we can use min max scaling.
Mm.
For normalization, you can also use sklearn package. So
Mm.
sklearn package is kind of like a machine learning package in Python, and you can
Mm.
use preprocessing.normalize, and it would automatically normalize to the mean, like the standard normalize standard scaling, like having normalized with mean and standard deviation. So if you will use this, you can see that now you have changed the normalized data. So this is the original, this is the normalized, and this is the scaled version. Now in the scaled version, you will see that the values were from 0 to 8. And in this case, the values are from 0 to 1.
Mm.
So this is the effect of normalization.
Mm.
So what we can do is we can either use scaling or we can use normalization. Okay,
Mm.
and how to do that? Let me give you an example of this as well. So let's say okay. So we have we want to use matplotlib.
Mm.
Okay. And let's say I read a data CSV file.
Mhm.
Okay. Let's see what the data is. So it's duration, pulse, max pulse, and calories. We have already dealt with this.
Mhm.
So in this case, you will see that the scale is different. Like the calorie scale is different, the max pulse and the duration. So either we can use standard scaling or we can use min max scaling. Okay, so if we use standard scaling, so what we can do is we can first get the mean value. So it means that after the first value, everything will be considered. And we dot stand, so we are calculating a standard deviation similar to the previous one. And what we will do is we will consider this scaled data. So this would
Mm.
minus mean and divided by standard deviation. So this is the formula.
Okay.
Okay, x
Yeah.
minus the observation minus mean divided by standard deviation. So
Yeah.
if we perform this, then I guess we can have our scale data. So now you can see
Mm.
that the max pulse is kind of like scaled with respect to normal distribution.
Yeah.
Okay. And if we perform min max scaling, so let's say we first have to um, calculate the min value,
Mm.
and then we have to compute the max value. And then we can have the scale data as in the same manner, but instead of subtracting it from mean, we will subtract it from minimum value and divide it with the range. And the range is maximum value minus minimum value.
Mm.
Okay. And if we see the scale data, you will see that it is between 0 and 1.
Yeah.
Okay. And what we can do is we can also use sklearn,
Okay.
and we can just use preprocessing dot normalize df dot, we can print the values.
Oh, almost. Submission, yeah, submission.
Input contains NaN. Ah, okay. Preprocessing dot
So it's very somehow one
okay. So
species.
first we need to have let's say updated underscore df dot, contains NaN. So what we can do is, okay, let's just, so we
Can,
can see
can,
that what is
can you do the
uh
find? Can you do a find NaN in the actual data set?
yeah, so we can find NaN that which value has NaN in this case. Yeah, so calories have NaN values.
What time? Yeah.
Okay, so what we can do is we can fill up the NaN values like we
Mhm.
did before.
Yeah.
So we can just use this,
Absolutely.
but instead of updated df, um, It would be df
Calories.
calories. Mm, calories fill in a. Okay,
Okay.
now I hope that, yeah, there are zero values, so now it should work. Yeah, so this is
Well
the
done.
normalized data.
Well done. That's super. Yeah.
Okay. Uh, Now what we can do is we can use the matplotlib to plot
Mhm.
the values. So let's say we have scaled data, not um, so standard scaling. We can plot scaled underscore data plot. Label would be min max scaling. It's normalized. You see that this is the standard scaling,
Mm-hmm.
and this is the min max scaling. So you can see that it's between 0 and 1,
Yeah.
but the standard scaling is between kind of like -9 to -5
Mm-hmm.
in between. And the normalized values are, you can see it is again between around 0 and 1. Okay.
Yeah.
So this is how we deal with this normalization. Now let's go towards cleaning data, how we
Yeah.
can clean it, or data we have already deal. Okay, so let's see. So this is kind of like introducing the concept of cleaning the data, how
Mm.
we can clean the data sets. For that, we have to consider that whether the data set is categorical or continuous.
Yes, yeah.
Okay. So again, the data quality issues are, it should be related to data sources. It should be automated selection error, incompleteness, value bias. We have already considered this. So I think that the core concept in this is that whether the data is in the series or data frame. And we have
Mm.
already discussed about series and data frame quite a lot.
Mm.
Uh, So in this case, I think it's all about series and data frame. We have
Yeah.
already gone through these slides in the previous lecture
Cool.
and how to combine them. Yeah, so we have already covered this in the previous week.
Yeah.
So let's go to data encoding instead. So why do we need data encoding and how to encode data in columns for specific tasks? So we will consider those, and then we can use Python with NumPy and Pandas to encode the data. So why do we need encoding? Let's say we are dealing with AI models and the model needs to process the numbers, but human needs classes to group classify. Okay. So remember that we did the encoding with the alter. What we did is we used big circles with respect to the title or
Yeah.
the year. So what we did is it in order to make the humans understand that what kind of data, what the data represents, we can encode it.
Mm.
And encoding can be done for AI models as well, because humans understand the categories, but AI model understand the numbers.
Mm.
And those numbers can be with respect to represented as different data types like categorical, numerical values, numerical ranges, boolean, date, time series.
Mm.
So what is encoding? It is kind of like transforming the input data into something that is more understandable by the machine.
Yes.
Okay. So there can be multiple like multiple processes of encoding, like single value encoding, vectorization, or one hot encoding.
Mm.
So single value encoding is like each string value is encoded as a single integer value. You can store properties within these values like word weight, distance, etc. The advantage of this is it is easy to compute and has a small memory footprint,
Mm.
but it gets larger when huge classes should be encoded. So if there are 10,000 classes, then it would make a mess of it. So in this case, you would see that if you have colors like red, green, blue, yellow, you can encode it with numerical values like 1320. And
Mm.
whenever red comes, then coding would give 1. Whenever green comes, then coding would give 3 or something like that.
Yeah.
Okay. And in this case, each value is transformed in array of numbers. So in
Mm.
this case, the advantage is it's high information gain. You can differentiate it easily, but the difficulty is that it has intensive processing. So let's say you have differentiated like each of the word in a
Mm.
Boolean variable, like the, red, dog, cat, eats.
Mm.
Okay, the red dog,
Mm.
cat eats. Now, in this case, the first is the red dog. So the red dog are present, but the cat eats food is not present. So they are zeros and the red dog is ones. Similarly, cat eats dog. In this case, the red is false because they did not appear in this. Dog appears, cat appears, and eat appears. Food does not appear, so it is zero. Dog eats food. In this case, the red is false, cat is false, and the remaining ones are true.
Mm.
So similarly, in this case, it's like a kind of a encoding vector.
Mm.
Now, in this case, again, you have gender, male and female, and not specified. So in this case, what you will do is you will just use the same encoding. Like if there is male, it would be 1, female 0, and not specified 0. For second, there is a female, so female is 1 and male and not specified are 0. For not specified, it would be this is true and others are kind of like false. So this
Okay.
is how the encoding vector works.
Mm.
So you will use encoding heavily when you will build AI model in the future. They
Yeah.
rely heavily on the data encoding. And
Yeah.
but again, which encoding to use, it's like it is dependent on which machine learning model you are using, what is the problem at hand, what kind of data do you have.
Mm.
So
Mm.
it all depends on that.
Okay.
And lastly, so let me just give you one example of um, data preparation. So let's
Oh.
say again, um, so let me see if I have that data. So is okay. So I have the data. So let's see if I can. Okay, so let me just close this and let me open a new notebook.
Okay.
So idea is that we should prepare the data. and we drop the columns that aren't useful. We drop rows with missing values, and we create dummy variables, take care of missing data, and convert the data frame into NumPy, divide the data set into training and testing, something like that. Okay.
Yes.
So let me first import the packages that are useful. Now what I will do is I will just delete. Okay. Now let's see what the data is. So it's kind of like Titanic data set,
Yeah.
which is available on the Kaggle.
Yeah.
Okay, so we can see the structure of the data set in Pandas using the infor method.
Yeah.
And if you want to see any specific column, so you can just see it like this. So embarked is here. Okay.
Yeah.
So again, what we want to do is we want to carefully observe the above summary of pandas. There are 890. So let me just okay. So there are total of 891 rows,
Yeah.
but age shows only 714 of them. See here,
Yes.
age
The
only
age. Yeah.
shows 714, which means we are missing some data. And embarked is missing two rows. Um, if you will, okay, so it does not show embark uh, because, okay, so it is not showing all of them. So embark is kind of okay. Let me.
That's where they got on the boat in terms of Sherbrooke or
Yeah. So
Southampton or
embarked
Kingston.
is missing two values, which is 889.
Yeah.
Total values are 891. And Kevin is missing a lot as well in this case. So it has only 204. And object data types are non-numeric. So this is object data type and this is object data type. This is object data type. So they are non-numeric. So we have to find a way to encode them to numeric values.
Yes.
So first, what we will do is we will drop columns that aren't useful. Okay. So in this case, let's try to drop some of the columns which won't contribute much to our machine learning model. We will start with columns name, ticket, and cabin. So let's say I define here name, ticket, and cabin. And what I will do is I will use drop NA
Yeah.
and I'll provide the subset as columns. And then I'll just use info. So in this case,
We talked about it.
name is still there. Why? And then we will use drop rows with missing values. So df equals to drop, and then we'll again use drop info. So now we have dropped the missing values as well.
Yeah.
Mm, all- okay. Now we want to create dummy variables, like let's say dummies equals to, and we want to have what?
Mhm.
Mm, what it does is instead of wasting our data, let's convert the passenger class, gender, and embark to columns in pandas and drop them after conversion.
Mhm.
Okay. And in this case, what we have done is you'll see that we have made female, male, and it's like the passenger class is C, Q, and S belongs to
Mhm.
embarked. 1, 2, 3 represent the passenger class, and these 8 columns have now been transformed into this.
Yeah, well,
So what we do
obviously,
is finally we
I
concatenate the
suppose,
origin. Yeah. Hello. Hello. Jim. Hello. Jim. Am I audible?
yeah, you can hear, I can hear you now. I lost you there for a minute. I don't know what happens if, as I haven't moved, but it means somehow it seems to, the connection seems to drop. I don't know what caused that, but I mean, it happened. Anyway, it's fine.
Okay. So now we would concatenate them. So in this case, we would concatenate data and this, but with x is equals to 1. And once we concatenate it, we would kind of like uh, drop p class because we have already encoded them. We would drop the variable this and we would drop this.
Okay.
Okay. So now we will take care of the missing data. So everything looks kind of clean now except
Mhm.
age. So age has some missing values. Okay.
Mhm. Yeah.
And which has a lot of missing values. So let's compute a median or interpolate all the ages and fill those missing age values. So how can we do this? We can use age.
Obviously, your age will be numbers really.
So now age has all the values. Okay. And if we see the DF, so this is now the DF. Okay.
Yeah.
Now we want to convert the data frame to NumPy. Now that we have converted all the data to integers, it's time to prepare the data for machine learning models. So what we do is we convert the data. So let's say x equals to df dot values, y equals to df survived is the class label. And if we see X, this is the array. Okay. So
Yeah.
X has still survived column in it. So what we will do is we will just use np dot delete x comma 1, x is equals to 1, and y is like the labels. So now we would kind of like divide the data set into two. So
Mm-hmm.
let's say from sklearn.model,
Mm-hmm.
we import
And test. Page on this bit.
and we use now to see that the split has done correctly. Let's take the shapes for the train and test sets. Okay, and how we can do that? We can see, let's say we have um, we can do it like this as well. Okay,
Mm-hmm. Yeah.
and let's say if we have take the shapes, the test set as well. So we'll see that 623, 623, and remaining 268 is the test set.
Mm-hmm.
Now, in the following example, like the code that I will write, we'll see that how label and binary encoding is done in Python. So for this
Right.
purpose, we will use scikit-learn library. It has vast possibilities in encoding nominal values. So let's say we can use from sklearn.preprocessing. We import label encoder,
Mm-hmm.
and from sklearn.preprocessing, we import one hot encoder.
Yeah.
So if we use label encoder, we will create an object, and we can use integer encoder. So we can use label encoder dot fit underscore transform, and we can use impact as the encoding value. If we see what it has created, you will see that it has created. Oh, sorry, it's encoder. Yeah. So you will see it has created 012. So the impact, which was SC or something, the classes have been transformed into integer values. Now, if you want to
Yeah.
use binary encoder, which is one hot encoder,
Mm-hmm.
so binary encoder can be done like encoder equals to dot reshape integer underscore encoder comma one. And if we use one hot underscore encoder, one hot underscore encoder dot fit underscore transform integer underscore encoder. So we can use integer underscore encoder to transform into one hot encoding.
Okay.
So you will see that it has transformed 0, 1, 2, 3 to a specific encoding technique. Like if it is 2, the 0, 1 would be false and 3 would be false. Only 2 will be activated.
Yeah.
And similarly, if it is 0, then 0 will be activated, 1, 2, and 3 will be false. So every time there would be only one activated and other would be false. So this is one hot encoder.
Mm.
So this is how we transform the data and encode the data. So if you have X train and Y train, you can train any model, you can test any model on the testing data, and then you can perform certain operations with the machine learning after uh, cleaning the data, after kind of filling the missing values, and after performing the encoding.
Mm.
Okay, so the next is that you have to design a small project which corresponds to
Okay.
movie data cleaning and transformation. Okay,
Yeah.
and the data set. So we have already seen this data set today. So you can use a movie
Right.
data set in CSV format containing columns like title, year, genre, director, runtime, and rating. You can use Alter, Vega datasets to import this data. And you have to load the dataset and perform an initial exploration to identify what issues there are. You have to handle the missing values and inconsistent data. You have to transform the data, let's say convert runtime to a numerical format, extract the data decade from the air column, create dummy variables from the genre column, and save the clean and transform dataset.
Now, will I have that data set when you upload this? We upload the data set, or where does as a data set in the trinkets or whatever?
No, you can actually import the dataset from Vega underscore datasets that we did. So if you
Oh,
import the Altair, you can from Vega underscore datasets, you can import movie DF. So it's
okay.
already in the pandas data frame format. So you do not have to transform the CSV into pandas data frame. It is already there.
Yeah, okay.
Okay. But if you have any issues, please let me know. You can email
Sure.
me and I can get back to you.
Okay.
Okay. So this is the last class. So please provide your feedback on the whole course and
Sure.
let me know if you have any queries so far. So we'll see how your like project and Jupyter notebooks go. I will check them and I will get back to you with the feedback. And if
Sure.
there are any issues, I'll let you know.
Great.
Okay. See you then. Bye bye.
Thank you. Thank you much very much, Sundar. Thank you very much for the course. I really enjoyed the course. I learned a lot.
Have a nice day. Bye bye, Jim.
Okay. Bye, Sundar.